They flew a metal brick for 45 minutes. United Airlines Flight 232 on July 19, 1989, faced an unimaginable horror high above the American Midwest. At 37,000 feet, the tail-mounted engine number 2 catastrophically failed its titanium fan disc, disintegrating into thousands of dangerous pieces. This uncontained explosion severed all 3 hydraulic lines, green, yellow, and blue, rendering the huge McDonnell Douglas DC-10 Series 100 completely uncontrollable through traditional means. The aircraft, with 296 people aboard, was instantly transformed from a sophisticated flying machine into an aerodynamic paperweight. The flight crew, Captain Alfred Haynes, First Officer William Records, Second Officer Dudley Dworak, and Czech Airman Dennis Fitch, were presented with an impossible command as the plane began an uncontrolled dive towards the Earth. They had to somehow steer this crippled giant towards Sioux Gateway Airport in Sioux City, Iowa, approximately 90 miles away, using only asymmetric thrust from the wing-mounted engines number 1 and number 3. This was a technique never before successfully attempted in such an extreme emergency on a multi-engine jetliner. The overlooked flaw, a tiny fatigue crack in the fan disc of engine number 2, had slowly grown over its 1900 flying cycles from an initial 1.6 inches to a critical size. At over 7,000 revolutions per minute, the disc tore itself apart, sending shrapnel through vital control systems. For 3/4 of an hour, these 4 brave individuals fought gravity and physics, trying to bring the 296 souls down safely. The emergency landing was executed at an insane ground speed, estimated at 250 miles per hour, significantly above the recommended 140 miles per hour for a DC-10. The impact was violent, breaking the aircraft into several large sections. Despite the overwhelming odds, 184 passengers and crew members remarkably survived the crash. However, 112 people tragically perished that day, a stark reminder of the unforgiving nature of aviation engineering and the critical importance of meticulous maintenance. The total flight time before the failure was around 3 hours after departing Denver. The investigation revealed the fan disc design had an inherent susceptibility to fatigue crack initiation and growth, making the single-point failure a catastrophic reality. The event reshaped aviation safety protocols, particularly regarding engine containment and hydraulic system redundancy. This incident stands as a monumental case study in crisis management and human ingenuity under extreme duress. The 3 hydraulic systems were essentially vaporized, making any pitch, roll, or yaw input from the control column impossible, leaving only engine thrust power for directional alterations of the enormous airframe. The final descent rate was estimated at over 1,600 feet per minute before impact, which further amplified the severity of the crash forces experienced by those on board. The incident led to major changes in inspection procedures for fan discs, ensuring that such an overlooked flaw would ideally never again lead to such a devastating outcome for 346 lives. A metal shred became an unstoppable weapon inside the engine. United Airlines Flight 232 faced an unprecedented fight for survival high above Iowa on July 19, 1989. The catastrophic failure of the number 2 tail-mounted engine at 37,000 feet began with a tiny fatigue crack. This almost invisible defect in the titanium fan disc, only 1.6 inches long, slowly grew over 1,900 flight cycles. Engineers later determined this flaw was virtually undetectable with existing inspection methods at the time. The fan disc itself, a massive component spinning at over 7,000 revolutions per minute, violently disintegrated, sending shrapnel at extreme velocity through the aircraft's crucial hydraulic lines. All three systems, the green, the yellow and the blue, were severed, rendering the 350,000-pound McDonnell Douglas DC-10 Series 100 utterly uncontrollable. With 296 souls on board, the flight crew, Captain Alfred Haynes, First Officer William Records, Second Officer Dudley Dvorak, and Czech Airman Dennis Fitch, faced an impossible command. They had to somehow pilot this massive 250-ton airframe towards Sioux Gateway Airport, 90 miles away, with no traditional flight controls. Their only hope lay in manipulating the remaining two wing-mounted engines, numbers 1 and 3, using asymmetric thrust. This novel technique was previously simulated only once, for a few minutes in a specialized simulator, and never executed in a real-world emergency on a large commercial jet. For 3/4 of an hour, these 4 men fought to keep the plane airborne, guiding it largely by instinct and raw engine power, amidst intense cockpit alarms and aircraft bucking. The emergency descent was fraught with peril. The plane's final impact speed, estimated at 250 miles per hour, more than 110 miles per hour above its safe landing limit of 140 miles per hour for a DC-10. Upon impact, the aircraft broke into several major sections. Engine 3, located on the right wing, was violently torn from its pylon, found hundreds of feet from the main wreckage site, an indicator of crash forces. The incredible effort saved 184 lives, but 112 people perished. The National Transportation Safety Board investigation pinpointed the overlooked flaw as the primary cause, leading to widespread changes in aviation industry practices. New protocols were developed for fan disc inspections, involving enhanced ultrasonic testing and eddy current methods, detecting cracks as small as 0.05 inches. Aircraft designs were modified to include hydraulic line redundancy and improved engine containment structures. This harrowing incident served as a stark lesson in material science, human resilience, and crisis management, shaping global aviation safety. The total flight duration before the catastrophic engine event was approximately 3 hours after departing Denver. The final descent rate before ground contact exceeded 1,600 feet per minute, a rapid fall that compounded the impact forces experienced by all on board. This tragic event reshaped aircraft maintenance and pilot training, ensuring better outcomes for future flyers. Every control surface went dead in an instant. United Airlines Flight 232 faced an unprecedented fight for survival high above Iowa on July 19, 1989, when a catastrophic engine failure at 37,000 feet began a terror. This event started with an almost invisible fatigue crack in a titanium fan disc, just 1.6 inches long. This tiny defect grew over 1,900 flight cycles, a flaw then virtually undetectable with existing inspection methods. The number 2 tail-mounted engine's fan disc, spinning at over 7,000 revolutions per minute, violently disintegrated, sending shrapnel at extreme velocity through all 3 crucial hydraulic lines, green, yellow and blue, severing them completely. This destruction rendered the 350,000-pound McDonnell Douglas DC-10 Series 100 utterly uncontrollable. A 250-ton airframe, now a plummeting mass without traditional guidance. With 296 souls on board, the flight crew, Captain Alfred Haynes, First Officer William Records, Second Officer Dudley Dvorak, and Czech Airman Dennis Fitch faced an impossible command. They had to somehow pilot this massive jet towards Sioux Gateway Airport, 90 miles away, lacking any conventional flight controls. Their only hope lay in manipulating the remaining 2 wing-mounted engines, numbers 1 and 3, using asymmetric thrust. This was a novel technique, previously simulated just once for a few minutes in a simulator, and never executed in a real-world emergency on such a large commercial jet. For 3/4 of an hour, these 4 men fought to keep the massive plane airborne, guiding it largely by instinct and raw engine power, amidst intense cockpit alarms and aircraft bucking. The initial flight duration before the catastrophic engine event was approximately 3 hours after departing Denver. The emergency descent was fraught with peril, as the plane's final impact speed estimated at 250 miles per hour, more than 110 miles per hour, above its safe landing limit of 140 miles per hour for a DC-10. Upon ground impact, the aircraft broke into several major sections. Engine 3, located on the right wing, was violently torn from its pylon and found hundreds of feet from the main wreckage site, a stark indicator of the immense crash forces involved. These incredible efforts saved 184 lives, but 112 people tragically perished. The National Transportation Safety Board investigation pinpointed the overlooked flaw as the primary cause, leading to widespread and essential changes in aviation industry practices. New protocols were developed for fan disc inspections, involving enhanced ultrasonic testing methods and eddy current techniques, which could now detect cracks as small as 0.05 inches. Aircraft designs were also modified to include critical hydraulic arm redundancy and improved engine containment structures for future safety. This harrowing incident served as a stark lesson in material science, human resilience, and crisis management, profoundly shaping global aviation safety standards. The final descent rate before ground contact exceeded 1,600 feet per minute, a rapid and uncontrolled fall that greatly compounded the impact forces experienced by all on board. This tragic event drastically reshaped aircraft maintenance and pilot training, ensuring better outcomes for countless future flyers across the world.